show up on our screen.
Yep.
There it is. Meeting is streaming live on YouTube, it
Oh my
says.
God, are we live, gentlemen?
Yep.
Oh,
Or the
okay.
Grateful Dead, one or the other.
That's true. We're very, very grateful to be alive. Let me tell you right now. My name's Ron Heron, and welcome aboard. Here we go again. Board members and supporters of Santa Barbara, California's longtime astronomical unit, the SBAU Astro Hour, is underway as our esteemed outreach guy joins us. It's the 179th issue, the edition, and we're ready without our president here, but I got a feeling we may hear from him. Nevertheless, I'm Ron Heron, your, I guess, chairman of Things Happening. I'll be running the board meeting and next Friday night, and I'm checking in with my psychiatrist to make sure I can handle it all. Meet at the museum. We meet at the Museum of Natural History, and it's this Friday night. Dr. Boldengau, why can't I remember his name? Nicholas Volganow. Going to take us to a big beer party in space. I kid you not. It was only 35 minutes long when I saw it at Las Cumbres Observatory's Astronomy on Tap Lower State Street bar back in March. But it should go about an hour when you add our questions on Friday night. You're all invited to come and join us. Heck, join the club. Go on SBAU.org, and here's the free astronomy talk. Ethanol in the ether. Thank you, Tom. Let me introduce you to everybody. Actually, let me just tell you what we may be talking about. Our orbits of the galaxy and our sun and solar system. We're going to tell you how many more there may be. We're going to talk about an extremely large telescope from ESO. That's not European space. What does that ESO stand for, gentlemen?
Probably
European Southern
Space.
Observatory.
Oh, Southern Observatory. All right. And from Chuck, he talks about a professor of fluid dynamics up at UC Berkeley who estimated or predicted 30 years ago in the mid-90s that Jupiter's Great Red Spot would be deteriorating and they're gone by now or within 50 years. We're going to watch that and see what happens. Tim Crawford had a question. Will rising water levels globally affect our weather? To which our esteemed president, who was on holiday in Western Europe, wrote back, no, all we do is lose Florida. And and in the heat, of course, well, everything's changing. We know that. Let's meet the gang, and then we'll see some silly cartoons. Thank you, Mr. Webmaster, turned man in control, Tom Totten, former president of SBAU. And here's Chuck McPartland, who may be leaving us at times, but you're going to be the heart and soul of this gathering. Let me tell you, Chuck, thank you for being there for us. Tom Whittemore.
Morning.
Is married to Maureen, I think. Let me make sure.
Yep.
That's right. That's your wife. Bruce Murdoch's wife is on the mend. She broke some bones, and I hope she shows up Friday night, bandaged and everything. But Bruce would normally be with us, but Tom Whittemore is married to Maureen. Tom Totten is married to Cezanne, and our secretary is not on board. He comes to the other meetings. Our treasurer and merchandise manager is Mrs. Pat McPartland. And son of a gun, there's Tim Crawford, who's married to Karen.
Howdy.
Can I call you the star of the Tuesday night workshop we've had on Zoom?
Well, no, but I am the mouth of the South.
I actually got to sit there for almost an hour and didn't say a damn thing.
There's some pretty cool guys on there.
Yeah, exactly.
Yeah, they're some pretty interesting subjects.
Well, I still think that Jerry Wilson, our beloved president, who is on holiday in Europe, or we say on assignment, he's supposed to bring us back stuff from Ireland. I have a feeling he loves this program so much, it's into its fourth year, that he just probably may be calling in or commenting on screen on YouTube or watching us. It's probably late afternoon or evening there in the UK.
I think he's 8 hours ahead of us, I think. So that would make it in the evening for him.
Jerry, it's not the same without you, but we're going to do our best, and we miss you. And
Well,
we got
he sent us some cartoons.
He's sending us cartoons. These are the silly science goodies.
You want to see those, Ron?
Yeah, throw those up on screen, and we'll get the hour kicked off with real madness.
All right. And talking about screens, the first one is all about New Year's resolutions.
Yeah, two futuristic computers talking. Hey, it's New Year's. What's your resolution? The other one says, same as always, 1024 by 768. Is that lines or pixels?
Pixels.
Pixels. Okay.
Which is,
I thought the
and then
1024 was lines. Here is a dreaded tardigrade. They survive in sub-zero temperatures. They can survive up in the vacuum of space. They're really an ugly creature, but look at that third box. That was the last day of the ABC Bachelor series. Heartbreak. It's over, Brad. Oh, no.
well, actually the tardigrade says, okay. It says K.
Oh, okay. Perhaps.
No worries.
Is that a one-cell creature?
No.
Okay.
Multi-cell, yeah.
So it's similar to mites. It's like a
Yeah.
What the heck would it be? What class is it in? What's it related to? It's not an insect.
No, it's kind of its own little thing, but they're just little animals that live in moist environments usually.
Does it require a microscope to see them?
No, I think they're visible, but not big.
Okay, but
Can
they're
you adopt them as pets? Can you make them a pet?
There's a bunch on the moon.
There are a bunch on the moon?
Yeah. One of the spacecraft, I think it was an Israeli spacecraft that attempted to land on the moon and ended up crashing, had a payload of some tardigrades in it.
What? It's not a form of a small caterpillar. It looks like it's got legs and it sort of walks, doesn't it?
Yeah.
Wow. I gotta look into tardigrades. Okay, next, Mr. Tom. Too much IQ level. Anyone want to add up all the IQs in that single picture? We got Albert in the middle, and I noticed Niels Bohr on the right, and he's sitting a couple seats away from Madame Curie and Planck. What was Planck's first name? Front row.
Oh, I don't know.
You guys want to identify any of the others that I don't know of? Dirac, Lorenz,
Curie, and Lorentz.
Schrodinger.
Yeah,
Schrodinger, Heisenberg, Pauli.
Yeah, Blancamer.
That had to be
Rack.
the annual meeting. That had to be, wow. How in the world did we get all those minds together with their bodies?
Must have been a physicist meeting.
Well,
Yeah.
we'll call it,
Richardson did fundamental work and basically expansion of the universe.
and that's somewhere in New York, in Europe, we think. It would be the GE College Bowl Olympics.
Yeah.
Wow,
right.
what a picture. Okay, throw that up larger.
Oh, by the way, Ron,
Yes,
Max Planck. I just remembered.
Oh, yeah, Planck Max.
Mox, spelled M-A-X?
MAX, yeah.
Yeah.
Okay, couple.
Blink Plank.
Here we have a couple of hapless American astronauts. One of them ready to do his own selfie, and he wipes out the guy next to him. We made it, war on the moon. Crash. I would probably
Gary
could have been
Larson.
all right. Here's one you can answer. God is using meteors
I would love this.
hit at the Earth, and why do the meteors always land right in a crater somewhere?
And next to a museum.
Yeah, right.
You know what? Yeah, put that arrow that there's actually the tourist. That meteor in Arizona is owned by a family, isn't it?
Yeah,
it's
it's the Barringer crater. The Barringer.
Yeah.
Mhm.
And it's like $29 to get in and get it to the edge and look at it.
Well,
So Ron, that was the crater that led Gene Shoemaker to basically say the cratering that we see on the moon was hits. It's not volcanic stuff.
yeah, see, Barringer was with an American Geological Survey that was out surveying in the late 1800s.
Mm-hmm.
And everybody thought these things were volcanic, but he knew there were a bunch of meteorite fragments in that area. And so he thought to himself, well, boy, those things have a lot of nickel in them, and nickel's worth money. So he bought the land, which is why it's called Barringer Crater often. And he mined it and got a couple of car-sized pieces, but he went bankrupt.
Wow.
And but his family still owns the land, and now they're making a go of it with this museum. So that's it turned out all right for the family.
Did you ever go to see that, Chuck?
Yes,
Yeah,
I've been there.
lived in Tucson, 14 years? I never went up to see it, darn it.
It's a nice little museum.
Yeah.
But that crater is about a mile across, you think?
Yeah.
Mhm.
How deep is that?
Pretty deep.
It's a couple of 100 feet deep. I think it was even deeper, but over the 50,000 years since it formed, it's acquired some sediment.
Yeah, okay.
So it would, if you walk to that edge, you'd be kind of a little frightened, huh?
If you're acrophobic, yeah.
Tim, it says it's 3,900 feet in diameter and 560 feet deep.
Okay.
Whoa.
Well, it says it's I don't get this. It says surrounded by a rim that rises 148 feet above the surrounding plane. Oh, okay. On the outside, it's 148 feet above the outside planes around it. Okay.
Well, I think I'll look at it from here.
Yeah. Well, at the museum there are some those silly little telescopes mounted on podiums that you can look at.
Yeah.
And down at the bottom, they have a cutout cardboard astronaut that you can, find at the bottom.
Pretty good.
Well, they say the sun is older than the earth, but water is older than sun. At least the water.
Keep clicking here in the wrong spot.
What happened? What are you doing?
Just when I click on the window, it went backwards.
Yeah,
okay, sun, earth, water, and earth is older. Now, is that? Oh, the water came from somewhere.
It landed on those very meteors we were just looking at the craters of.
Yeah, and it was part of the solar nebula. So,
well, obviously, if it can happen here, it probably happened on Mars. But Mars just lost all of it, didn't it?
Well, not all of it. There's quite a bit there.
I mean, why would they say the sun is older than Earth? They're kind of formed at the same time out of material that came from maybe billions of years old for both the sun and for the Earth. So that's really not true, is it? The sun is older than Earth?
Well, we continued forming after the sun was ignited, after it ignited fusion. So
we were just
don't think we formed at the same time?
Well, yeah, but not in our final form. I mean, then there was the Theia impact and all that other stuff that went on.
Dust and gas and beer mash.
Yeah.
Let's see. Do we have another cartoon here?
Oh yeah.
Get these thought provokers. Bruce Murdoch emailed back when this went out. This is not possible. You want to explain it to me? What do those sides mean? Looks like a right angle triangle. A right triangle? Is that what that is?
Yeah.
Well, I is equal to the square root of -1.
Right.
And so if you square, what is it? How do you look at that?
A squared plus B squared is C squared. So
it will give you 0.
Yeah.
Because I squared Tom is -1.
Oh, it's -1.
Yeah, -1 and 1 squared, of course, is 1, and 1 plus -1 is 0.
So that's a Pythagorean theorem, but with an imaginary side.
Right, and Pythagoras is probably rolling over in his grave.
So I squared is -1 and not +1?
Yeah,
it's -1.
I squared is -1.
Huh, okay.
It's a foundational, imaginary number, Tim.
Okay.
It makes radios work, your computer work, everything.
That's beyond my mind. I don't comprehend that imaginary number stuff.
Yeah, that was one area of mathematics I got lost in.
Now, do we see this already?
Here's another one that nobody figured out yet. Don't claim to know anything about space if you cannot even tell somebody what the heck this planet is.
No, I don't understand this one.
That's a character from a SpongeBob SquarePants movie. But I don't know what the name of the planet is.
Oh. See,
well, I was naming it Kunta Kinte because LeVar Burton starred later on after Roots.
Oh, yeah.
In one of those Star Trek, and he wore some sort of a strange pair of Buster Grant glasses. But okay, so that may
it says is that it says SpongeBobia? No, let's see, that's not right.
SpongeBobia.
The Earth, also known as SpongeBob's world, is the third planet from the sun and overall main setting in the SpongeBob SquarePants franchise. It is a lush and beautiful planet in SpongeBob's universe, similar version of the real Earth. So maybe it just means planet of the jellyfish. But no, that's an episode. Anyways, it's SpongeBob's planet, I guess.
Well, look it up. You got Nick can report next week, and we'll call it up again.
That's a planet. That might be a picture of the imaginary number.
Yeah.
Very imaginary. Yeah, we saw this one already, didn't we?
Here's
Yeah.
a cell
Yes, a good
feed,
one.
yeah, using a cell, but unfortunately, microscopes don't take good pictures. But
All right. All right. I guess that's the cartoons for the week.
get a glass
Okay.
slide there, gentlemen. Well, without the president guiding us through, and I didn't have to read a whole long scroll of talking points, we're sort of on our own. Can
So
we,
shall we go?
go ahead?
Shall we go to Jupiter first?
Yeah, that was my
Yeah.
suggestion. The red spot, Chuck, is it declining or not?
It seems to have a 70-year color change cycle, and it does expand and contract. There have been images showing a much larger spot in the past. So it definitely changes size. Yeah, as you can see here. Of course, that drawing is a little fanciful, but it probably gets the size right. And so this guy, Professor Marcus up at Berkeley, came and gave a talk at UCSB, in the 90s, speaking about how he was studying these magnetohydrodynamics going on in the planet's atmosphere and these vortices and how they interact. And he saw that it was declining, and he thought it would actually go away, sometime in the next 30 to 50 years. So we're getting close to that 30-year part, but who knows? It is shrinking. It's smaller than it's been in a while, but it's also redder than was redder than it's been in a while last year.
Yeah, I was going to say, Chuck, I remember going out to outreaches where the red spot was actually pretty light.
Yeah.
Hmm.
Yeah, it was
heard-
almost the great flesh-colored spot for a while.
Yeah, yeah, it was really, really light.
Yeah,
they
for
know
people
why
who
it's-
want to just see it in a more mundane fashion, it comes up not too far from Aldebaran now. Something like 1:30, 2 o'clock in the morning. I think I saw it this morning come up.
So in a couple of months, we'll have it at reasonable hours.
Mm-hmm.
Okay, and somewhere I read that it's not the same red spot they used to have. It keeps reforming or coming and going.
Right. That's another
Theory.
speculation there is that it comes and goes.
Well, I can recall it being 3 Earth sizes, and then it became 2 Earth sizes.
Yeah.
And the picture we saw there a second ago was, God, a whole bunch of Earths could have fit in it.
Yeah.
Yeah,
Hmm.
right there, on the right.
There used to
Something
be
else-
an app that you could go to that would tell you what times the red spot would transit, and it was pretty accurate. But it's gonna be coming around about every 10 hours. Is that right?
Yeah. Uh-huh.
Right.
And Sky and Telescope has a little app that will tell you when the Great Red Spot transits, and Sky Safari, a bunch of the phone apps will do that.
Well, is there any similarity, gentlemen, between what we're seeing there on Jupiter and our northern and southern, I guess, hemisphere hurricanes? The
Exactly. Yeah.
Coriolis- Is there a Coriolis effect on on Jupiter?
Yeah.
Okay, so why wouldn't it give a bunch of red spots?
Well, you see those little white ovals, those are the same kind of thing. Just above the red spot there.
Oh yeah, yeah.
Those are small spots.
Yeah, they're storms too, and they're vortices. They just
Now,
don't
those
have the red color.
And there was a junior red spot.
Right. There was a red spot. There was a great red spot, the not so great red spot, and the red spot junior for a while, but then it gobbled them up.
Oh, okay.
Well, is there a
The big
southern?
red spot gobbled it up?
Yeah.
Oh, okay. I didn't know that.
I don't see much going in the southern hemisphere, just like on Earth.
Well,
Do they
there's some vortices down there, but yeah.
Well, do we have the equivalent of our hurricane season down in Rio de Janeiro, or only a half a year later, I guess, when they have summer?
I assume summer you have more energy in the atmosphere, more heat. You'd get more of that.
And the ones they
Oh, go ahead, Ron. Sorry.
well, in Asia, they're called monsoons, but they're exactly the same thing, just with a different name.
Well, monsoon is more the rainy season.
Right.
They call them typhoons.
Typhoons.
And
Typhoons.
yeah.
Well, I got news for you, gentlemen. We now have a rainy season, not monsoon. It's in December.
I've really never understood the red spot. Why, just what exactly is it? I mean, I know it's a storm, but why would it just form in this one region?
Well, once it forms, it kind of persists. It feeds off those other other storms, because it's not along a boundary between two of those jet streams that are going in opposite directions.
So that's probably what formed it right there.
And that spins it up. Yeah. And the red, they think, is from phosphine. I think it was the compound. It's some chemical compound that it dredges up from lower in the atmosphere, and that turns red when it's exposed to ultraviolet light.
And the winds are something like 400 miles an hour.
So Chuck, did you say phosgene?
Phosphine, I think.
Okay, because I was going to say that was used in the First World War.
Yeah, it's a pretty good gopher poison too.
Oh my God.
But maybe you used it in some of your sourdough bread, Tom. I didn't know.
No, we have snakes here that take care of our gophers.
There you go.
Do a good job.
Right.
Yeah, red
some
snakes
over here.
Yeah.
Aren't there big storm spots on the other gas giants?
Yeah, there are storms that erupt periodically on Saturn.
Okay.
And there's a great dark spot on Neptune.
Oh, it's Neptune, not Uranus.
Uranus seems to be quiet.
Well, it's now named Doug.
Doug, yeah.
Thanks to a fast cartoon, because people are keeping calling it Uranus.
Right.
So what? Okay, fascinating stuff, gentlemen.
Oh,
We're
You
not
see
having
this
talking points.
one comment that says where after 1713, the spot seemed to disappear. Then the next known sighting was at 1831. So over 100 years later, that's when somebody else started seeing the red spot again.
Okay.
So there's
Pretty
some evidence that it comes and goes.
mm-hmm.
So there's
100 years without a spot.
Wow.
That's crazy.
So it's kind of on a belt in between the two zones.
Yeah.
And that's what spins it up. Okay.
when you call a gas giant it's not all gas. You reach a level down below where it's liquid, isn't it? And then hard in the middle, solid.
It's more like a big fluid ball, I would say, than calling it a gas giant. But yeah.
But I mean, gas giant meaning the surface is gas. That's where a storm would be. You couldn't get a hurricane in the ocean, inside the ocean.
You can get whirlpools in the ocean.
Guess you can't you? Heaven forbid a ship should run into one. Guess they have.
So Ron, how many Earths can you fit inside Jupiter?
In Jupiter? It's got to be
That's a Chuck question.
About 1,300.
Yeah. I knew it was more than 1,000.
And then how many Jupiters fit inside the sun?
In the millions?
No, it's millions Earths, but I think it's 1,000 Jupiters.
1,000.
1,000 Jupiters in the sun, and then 1,000.
Yeah, I mean, just Tom, just roughly, all you need to do is take the relative size of, the diameter of the planet or whatever you're thinking about to the diameter of the Earth, and then cube it. So if something is 10 times as large side to side, it's going to have, in the ballpark of 10 cubed, 1,000, time volume. It's just real rough.
I think Jupiter's 11 times the diameter of Earth.
So it's ballpark 11 cubed, it's just ballpark.
And doing a whole turn and going around in 10 hours. My God.
Mm-hmm. Yeah, that's really moving. You can see it. You could see it's elongated in the middle.
Is it a dark, what's it called?
Pale star?
Brown dwarf?
Brown dwarfs are bigger.
Oh, they are.
Yeah.
More massive.
Well, they're more massive. They're not necessarily much bigger.
Mm-hmm.
What's different about them other than being massive? Does the brown, is it sparked or lit or?
I think it's because they're on the threshold of fusion, and they can maybe fuse deuterium, but not hydrogen.
Yeah.
Well, if you saw the non-Kubrick 2001 Space Odyssey 10, the follow-up, at the end of that movie, it lit up. It became a star because of all those black monoliths in space. You had to have seen it, I guess.
That's right.
Okay.
So I thought it was interesting. I think Jupiter, somewhere in the atmosphere, it's like 400 degrees in the atmosphere of Jupiter at times, even though it's 5 times farther from the sun than we are, that the atmosphere of Jupiter.
If you go down a few levels.
Mm.
So
but it does radiate more in the infrared and radio than, overall it radiates more energy than it receives from the sun.
Right. So that's probably that's gravitational, right?
Mm-hmm.
Yeah.
Would Jupiter float in the bathtub, Chuck?
No,
No,
Saturn would,
Just Saturn would, yeah.
but it leaves a big ring.
Always leave it right.
I love that. I love that.
But so it shows Jupiter's mass is 318 times that of Earth, but you can fit over 1,000 Earths inside Jupiter. So Jupiter's density is much less, one quarter that of Earth, I guess.
Mhm.
But
And
not light enough to float in the bathtub. Okay, now here it says theoretical models indicate if Jupiter had over 40% more mass, the interior would be so compressed that its volume would decrease despite increasing amount of matter. So that's kind of like how, if Jupiter was 100 times more massive and turned into a star, would it be necessarily bigger, or would it actually be so compressed that it's about the same size?
Would it be something if they discovered in the future that way down deep there's life inside the liquid?
Tardigrades.
Yeah, right.
When I was young, growing up and first learned about Jupiter, the thing I thought about was, oh my God, you land there and you suddenly weigh 1,000 pounds. Oh, what is this? Is this Jupiter with its rings?
Well, it's showing all the layers of Jupiter here. So clouds are 50 kilometers thick. What else are they showing? The Great Red Spot. They're showing that the south and well, hold it. L and H. What's that mean? South belt, equatorial zone, north belt. Oh, so I'm not sure what the L and the H stand for here. But
so it's got a ring system just like Saturn. We just can't see it the same.
And you're talking about so gas, liquid, helium, neon, rain. That's crazy. And then metallic hydrogen. That's crazy stuff.
Wow.
And then rock and ice in the middle. That's weird.
I think that's an old model.
Yeah.
Because with the results from Juno and the Galileo probe, they measured the gravitational field, and it looks like it's very little rock and ice core, and it's more just all in solution with the metallic hydrogen.
Yeah, not mixed. Huh?
Yeah, it mixed more than this shows.
And
it seems to have these weird vortices in it because it's got a really complex magnetic field with multiple poles.
This picture doesn't make much sense here, because why would the red spot, the great spot, be staying in the same place even though clouds are moving?
In the equatorial section.
It does drift. It just drifts at a slow rate. So if you see those, like the app on Sky and Telescope, I think you can go look up somewhere what the current longitude position of the Great Red Spot is to get a more accurate prediction. It assumes a certain rate of drift and a certain starting position. And so do most of the planetarium programs, but you have to go and periodically update them with what the GRS longitude really is if you want them to be really accurate.
Okay. Here it says at the bottom, it's a time lapse of Jupiter's cloud system moving over the course of 1 month, photographed by Voyager 1, 1979. So,
yeah, and they're taking it at like the same, like at a sun synchronous longitude to pace this together, because otherwise it'd be spinning like crazy.
Right. Okay.
Well, it has something in common with the sun then, doing that, doesn't it?
Yeah.
And here's the top view, top or bottom. Let's see.
This would be Juno, yeah.
Stereographic, polar stereographic projection, the south pole.
It becomes one of those.
Cassini.
2000.
Cassini must have flown under it, because Juno is the one that's getting the good high latitude pictures.
Yeah.
Cassini was only Saturn, wasn't it?
Well, on the way out,
here's Juno. This is Juno.
Yeah, look how complex that is. That looks like a fractal.
Looks like a mess. The ghetto section of Jupiter here, folks.
Southern storms.
I once heard Jupiter referred to, the solar system was simply Jupiter plus debris. We're sitting on some of the debris.
Or the sun and Jupiter and debris. Yeah.
Well, the sun, yeah, obviously. There it
I think
is.
the sun is 99.9% of all the mass in our solar system.
Yeah.
Mhm.
About 1,000,000 miles across. So,
So
wow.
there's June. That's a Juno red spot picture.
Well, dumb question time. So I'm going to throw it at you. All those gas giants have rings, and I think all the rings are right around the equator. Why is that? Why can't it flip on its side and turn like Neptune, but leave the rings where they were?
Then it's not dynamically stable from interactions with the effects
the
of the
ring?
rotating planet.
Really? Okay. Are all the moons along that ecliptic?
The moons that formed with it are along that equatorial plane.
Oh,
But the
okay,
moons
but
that
other
are
ones that
captured
they've
are the
been.
ones that are in high inclination orbits or that interacted.
What's that thing on the top we're looking at?
Those are auroras.
Oh, of course. I knew that. I was just testing you.
Another aurora picture.
But there's not a six-sided aurora, is there, like on Saturn?
Maybe occasionally. I mean, it looked like a really multiple-sided one there on the South Pole.
Have they explained that phenomenon? Do you guys understand it? On Saturn?
That's probably a question for the fluid dynamicist guy.
Yeah.
How do things that are whirling around a pole suddenly go straight for a while and then veer off again?
That's probably has to do with the viscosity of whatever it is.
Okay.
Those are the moons there.
Yeah.
Yeah, there's a shadow that traveled through, Tim.
Wow, there you go.
Don't know what this stuff is. Let's see.
Some ancient
Letter.
notes.
Somebody
Talking
looked
about
at
Jupiter.
Galileo wrote
Letter
this.
T. Before they had a great red spot, they had a T.
Yeah.
Wow.
Another infrared James Webb infrared shot of Jupiter. So
Well,
You can see the heat coming up in the great red spot.
north and south. Yeah, I don't know. Yeah.
does anybody keep track of the Juno schedule? It comes in what, every 55 days or something?
I think it's
Whoops around.
50 something.
Otherwise, it's way out there in space.
So if we could see radio waves, this is what Jupiter would look like.
Really?
That looks like the Saturn Nebula.
Or a chameleon.
Like a coat of arms.
Yeah.
With big ears.
Looks like a coat of arms of the Scottish guy, Braveheart. Look at that. Wow.
It's a Galileo, 1989.
Okay, take a look at that antenna. That's the one that failed.
Really?
It didn't open all the way.
Oh.
So they couldn't get it was asymmetrical, one part stuck. So they couldn't get the data rates they expected.
Oh.
We're talking about the dark colored black cactus or barrel cactus on the top.
Yes.
That didn't go open.
It didn't unfold all the way. It unfolded partially.
What's it sitting on?
That's just a backstop of some kind there for it.
Oh, not a Parker probe type barrier or shield.
No, I don't think so. It might have been
just an antenna reflector or something.
Yeah. Not solar panels.
No.
Oh, okay. But everything in space has solar panels somewhere.
Right, but they didn't have the solar panel technology to do it with Galileo.
Oh, is this old enough to be? Okay, got it.
Right, at that distance. Now the Juno has huge solar panels.
I'll bet. Yeah, we see that size of the bin next to it. There they are.
So Juno's not using hot boxes, huh?
Right, yeah.
Juno has.
This is Juno. Okay.
What do you mean hot boxes, Tom?
Radio, was it?
Radioisotope thermal generators.
Oh, okay.
The little plutonium reactor things.
Here's the moons.
The biggies.
Big ones.
How does our moon compare to those? Bigger?
Our moon is about the size of Io there, that was the one on the left.
Oh, really? Io's as big as our moon?
Yeah. Probably.
And
Europa
is smaller.
Smaller.
Europa is smaller, yeah. And And there's Shoemaker-Levy comets
Yeah.
impacts,
Yeah.
And those
bruising.
impacts persisted for quite a while, so that was
Right.
really energetic.
Yes.
Well, they all crashed on the opposite side, and we just
Mhm.
got to see the
Mhm.
flash or the leftover cinders when it came around, didn't it? We didn't see any of the explosions.
Yeah. So,
So can
but
you explain the symbolism here? What's going on here? Zeus is being pulled by a couple of birds here.
Well, I think that's, yeah. And you can see Sagittarius there in Pisces, so probably
yeah.
talking about something about its orbit.
And what's with the eye in
That's
in
Roman.
Jupiter versus?
Roman.
That's
Mhm.
the way they used to spell
Yeah.
Jupiter. Wow.
Well, hold it. So I mean, is it is it Ipiter as opposed to Jupiter with a
It's probably more like Jupiter.
Yeah.
Or forfeiter.
Okay. All right, that's the last one of that one.
Yeah, that's enough of that.
Stop share.
Okay, what else do we
else?
want to go to then, gentlemen? That exhausted the topic of the big gas giant and Jupiter, and
Hold on, I'm having problems here flipping screens. Looks like my
you're
stop
doing a
share
good job. You're doing a great job.
is I'm having a time delay for some reason. Getting
Well,
out of stop sharing.
on a jokey note, last night there was an asteroid occultation that I couldn't resist because it was the name of the asteroid. It's Bradychuk.
Radychak?
Bradychuk.
Ratty-
And so went out and tried for it, and I visually I could see the occultation. So the asteroid passed in front of the star and made it wink out, but it was a magnitude 13 star, and I only have a 5-inch aperture telescope to do it, and it was low in the south, so it was really noisy. But here, I mean, if you want to get bored by this, here's the graph.
Oh, hang on. We have to get Tom to.
Is it okay if I share here?
I don't think you can.
I think I'm kind of getting stuck here, so
Stuck. Okay.
I don't know.
Anyway,
I'm not gonna know what is here.
there's
Did I turn my sound down?
oh, that won't have anything to do with it.
You
No.
said
There's a hugely noisy graph of the occultation, but
okay.
Well, you said it was 100%, so that means everybody was going to see it, right?
yeah, everybody who tried for it, but I think it was only me and one other person if he didn't have clouds.
Okay.
Oh dear.
So
Uh-oh.
it was a star occultation. It wasn't the moon this time.
That's correct.
Okay. Which star? Do you have that name?
Yes, I do. It was UCAC 4 314 234 254.
Oh, that one.
Yeah.
All those telephone numbers in space.
Yeah, I get spam calls from that star all the time.
Oh dear.
The center line was closer to the shoreline, so I was initially going to try it from Butterfly Beach,
Oh,
Yeah.
from Channel Drive or whatever that is there. But it looked like the marine layer, there was haze and stuff coming in. So instead I went up by the Cater water treatment plant,
oh,
got above some of the haze.
Wow.
that's
Of course,
near
I was
us.
under a street light too, which didn't help.
Yeah, that's just around the corner here.
Yeah.
Mhm.
So it would be safe to say that every damn thing out there, every star, every asteroid, it's got a track not only of where it's been, but where it's going, and somewhere inside a large globe is a million lines. It's like a ball of twine, isn't it?
You could do that. Yeah.
Mhm.
To know where it's going to intersect and when. And my God, where is all that housed? JPL? Where do they have it all?
Well, it's just equations, it's just different coefficients that you plug into an equation to get where these things are going to happen.
Mhm.
You suppose you could find them online on a computer?
Sure.
Find,
Sure. There's a JPL ephemeris generator out there you can go to.
but
And
most
there's
of the stuff
a cult, it's called a cult 4 or Occult Watcher, there are different programs you can go there to get the predictions for the occultations. Occult Watcher Cloud is on the web.
Well, what's the official confirmation process that you actually saw it happen? Do you get to check in and claim credit somehow?
Well, it's not really credit, but yeah, you run an analysis program on it, and you send your data in, and they verify it, and then it gets published to the Minor Planet Center to update the orbits.
But a lot of times, due to the size of the Earth, you could see an occultation, but it wouldn't happen 100 or 200 miles away, right?
Well, the path is only as wide as the asteroid, yeah.
Right. So what you hear is only for this area where we live?
Well, that's all I look for, yeah.
So they'd have completely total different ones in Poughkeepsie, New York, or Sarasota, Florida.
Yeah, unless it's a really big asteroid and moving slowly so that there's a long path.
Oh no, that's not good.
Uh-oh.
We stopped recording and we lost Tom.
And you're the host now, Ron.
Yeah.
He had to check out. He had to check out, and then he's gonna log back on.
Yeah. Okay. Well, I guess this is the intermission.
Yeah, this is the adventure here.
It's time to go get some popcorn or some of Tom's sourdough bread.
Yeah.
What's the status of Bruce's wife, Bonnie? No, he's not married to Bonnie.
Yeah, that's Bonnie.
Yes, he is. Bonnie.
She's
she's
okay?
recovering.
Okay.
She's hopefully going to be home on Thursday, last I heard.
Okay.
She fell and broke her arm right by the elbow, so they had to reconstruct her elbow and lower humerus, and she also broke her fibula in her leg, and they put a steel pin in there. But she's up and walking, and she's enduring hours of physical therapy right now.
Yeah, that place is a miracle house, Chuck. The place at De La Vina.
Yeah.
And did poor Bruce have to take her out or take her there or call for the ambulance, you suppose?
Oh, he probably called an ambulance.
Yeah.
Well, no, but she's laying there in pain. What do you give somebody that's screaming in pain? I can't imagine breaking a bone. Never have, but half of us are supposed to fall.
Well, in the movies, they make something else hurt more.
Yeah.
so that you don't pay attention to that pain.
Yeah, they take your mind off of it.
There's a Sunday night program on ABC called America's Funniest Videos, and fully half of them are men usually getting hit in the crotch by a ball, and everybody laughs like hell when he doubles over. They never show the real effect.
Sadistic pleasures, huh?
Hey, Tim, maybe we could talk about your new telescope.
Yeah.
Yeah, I was thinking about when we were walking Wally this morning. You have a 6-inch f4, right?
I do.
Yeah, so that will have a focal length, 150 millimeters times 4, 600 millimeter.
Yeah, it's around 600.
And if you put a 10 millimeter eyepiece on that thing, you'll get 60 power, right?
That's right.
And if it turns out your eyepiece is at least effective 60 degrees, you got a 1 degree field of view of the sky. That's pretty neat. That's the beauty of these things,
I tested this with a 10 rating. Now they don't.
Oh, that's it. That's your 60 power, Tim.
Yeah, and the ratings were
57 degree effective field.
Right? Yeah, so it wasn't up there like the Naglers, but I have other Naglers. I have a 9 Nagler, type 6, which would be awesome because that.
Well, the other thing is that with a radian like that, a radian eyepiece, which is nearly 60 degree field,
right?
You're going to get 2 moons. You get 1 degree right across. It'd be
nice. And it's when I was testing this this little scope, and let me just see if I can do this. If I can, I'm just going to throw this up on the screen.
Okay, so request a screen share, and Ron should be able to say it's okay for you to share.
Okay.
There you go.
Yeah, and so this little scope, the story of this is I was going out to Tom Totten's, who will be back soon, and he's kind of our equipment manager now, and he's got this garage full of stuff. and we were
I'm back, Tim. I'm listening, but my video's not working.
Okay.
So I was looking at, we were going through his garage and kind of like listing stuff. Now I wrote an article to Tom. Who's going to use it in the newsletter, and I kind of told the story of how this all happened. We were going through his garage, and there's all these scopes, and we had just picked up we picked up a couple of scopes from this lady's house who just lost her husband, and one of them was a 12.5 Newtonian that reminded me of Joe Doyle's old Beast. It was huge thing. And Tom and I loaded that up. Well, mostly Tom. And then I think there was a 6-inch refractor, wasn't it, Tom, that she had?
Yeah. It's Celestron AVX mount with the 6-inch refractor on it. Yeah.
Wow. So it's got a lot of neat stuff laying there. And we were on the way out, and there was this little dinky tube that was just kind of standing up in the garage at the front. And Tom he saw me looking at it. He said, "Oh, here's a little 6-inch telescope here in this small tube." And the color of it reminded me of the Takahashi stuff. Wow. And I said, "Well, that's kind of neat." And I looked at it and I said, "That looks like a fiberglass tube." And Tom said, "Well, should I wrap it up?" I said, "If I brought anything else home, my wife would kill me."
Yeah.
And so the next time out to his house, I said, "I don't care, man. I want to get this thing." So I took it home. And it turned out I took this apart, and the little mirror cell in the back, you can see it at the back end there. There's 6 screws that hold this mirror cell in, and some guy had put the scope together on the back end of it. If I can get this picture, I'll show you what he did, and it was really goofy. The guy had here. Oh, well, that's not the good one. It's here.
We may be
these two should be okay.
We might be back on, guys. So this is part of the program. We're not just stalling. Yeah. There you go.
I think it's still going. I think you're still going to YouTube. So I'm just not back.
This is the back of this mirror cell. And somebody had taken these nuts that are in the center there, and where you see the wing nuts at the side, they just cranked them down.
Ooh.
And those are to collimate the scope. You can't collimate it. It's the thing that you put in there. I was having the hell of a time getting this thing collimated.
Sure.
So I took the thing apart and I replaced these nuts with wing nuts. So it's all spring loaded and everything. It was real easy to collimate. Turns out the mirror is a cave mirror, a 6-inch f4 cave mirror, which is some of them were really, really good mirrors. And apparently this is one of them.
I see.
And it was just a wonderful little scope that I had and put together, and it's a neat little project. And we're going to have a little letter in the newsletter about how I put it together.
September issue, would be fun. Yeah.
So it was fun. It was fun to make, and for one time, Ron, I didn't actually grind the mirror. It came with a mirror, and so I was thinking to myself, boy, this is the way to go. You don't have to grind the mirror and take a long time. Just put it together.
Could I see it again, Tom Totten? Can you call it up? Because there's something strange about it.
Well, it's the nuts that the person put on there. They probably thought, "Hey, it's collimated. I'm going to lock it down, and I'll never have to change it."
The original picture showing it sitting out there. I've been waiting to ask a question about it.
That one there.
Yeah. Now it seems to be pointed down on the right. But the part you look in is that the black attachment on the left? That's up.
Yes. It's a Newtonian, Ron. You look at the top end.
Yeah.
Yeah. So where the focuser is on the left, that's where the light is coming down the barrel, and it's hitting the mirror, which is on the right side, and then it bounces back to a little diagonal and out into the focuser. So how this thing worked is that like I said, my wife was going to kill me if I got this thing, and so I thought, well, how could I do this? And it's small enough to hide. And I took it home. And I said, I have this base for the 8-inch that I just made. And what I wanted to do is put it together in such a way where you could actually take 2 little plates of wood and put it to the inside of the old base, and then set the tube right on top of that. So this thing could actually be used. If I can go back, maybe I can do this. And it won't take any time, guys. I'm going to try and do it real fast.
Tim, did you make that little curvy adapter for the JMI? Looks neat.
I did. And
yeah, it looks
and
beautiful. Made out of wood.
It
Looks
was
like,
out of mahogany. It was out,
yeah,
out
that's
of mahogany.
beautiful. Yeah, from instrument making stuff. Yeah.
Yeah, it turned out pretty good. I'm trying to find this other scope so I can show you.
Tim, I don't understand how you made that wood curved piece. I'm very curious how you carved that out.
Router.
Yeah, it's much easier. See, the thing is, I have an oscillating spindle sander here.
Ah.
And I also have a jigsaw. I'm trying to find this other scope so I can show you guys.
So your jigsaw can handle a 4-inch piece of wood in a jigsaw vertically, kind of to cut that curve on the.
Well, let me try and find this other.
If I'd made that, I would have used a router, but Tim's got some snazzy equipment.
Well,
and Ron, this is the beauty of making things with your own hands, you know. And Tim is quite a craftsman.
Yeah.
Except when you lose the finger, but yeah.
And it's a way to, he's using the same baits for 2 different telescopes.
That's right.
Yeah, that's what I'm
so
trying
neat.
to find is a picture of this other scope, and for some reason I'm having trouble, guys. I'm
yeah,
so
Tim.
sorry.
I had another thought when this F4 is so fast, right? 'Cause I make scopes like this, or I used to anyway. If you think of wasted light or getting all the good light to your eye, if you assume like a 7 millimeter entrance pupil for your eye, you're limited. You're limited to eyepieces, Tim, that are less than 7 times 4, 28 millimeters. So don't put a 40 millimeter eyepiece on that unless you want light to go around your pupil.
Well, I have a 35. I tried the 35 panoptic in this.
That's going to be wasted light, but I'm sure it'll be, just beautiful.
Well, the way it is right now, I can't bring some eyepieces to focus, and
right. That's what you said. And I wouldn't cut
some
holes in that darn tube, Tim. Just use what you can.
I got here's the little piece of wood that I cut.
Yeah, that's neat. I was wondering about that.
And so what you do is you cut rough it out with a bandsaw, and then I have the spindle sander. You can hold it. When you have your line on there in pencil, you can hold it up against the spindle sander and you can sand a really neat little curve. The problem with this thing is it not only has a front curve, it also has a back curve. And here's the back of it, and that's supposed to fit the focuser in that first image. That focuser, the bottom of that focuser, has a gentle curve to it as well, maybe for a 12-inch or 6-inch radius. And whereas the other one has this is a 7 1/4-inch tube, so I had to use a 3 3/8, I guess it is, or 3 5/8. I can't remember what it was, but anyway, I used that radius. So I cut both radiuses, and I'll be darned if it didn't.
That's pretty nice. Yeah.
So Joe Doyle told me what you can do, since I can't get some of the eyepieces to focus. I needed a real low profile focuser. That one that came with it was really short, and it's really old, and man, it was really horrible to use. So in this, Joe just says, if you can move that mirror cell at the back of this image, move it forward like an inch. And I said, it's funny that you say that, because when we got this 12.5-inch scope that Tom and I got from that lady, that big 12.5 had different holes that were drilled into the tube for placing the main objective forward or back. It was amazing. Remember that, Tom?
Yes.
There were holes that went forward and back, and so I said, shoot, that might be possible. And well, that would allow me a little bit of to get that focuser to work a little bit more with more eyepieces. So we'll see. Maybe I'll do that. I'm going to stop right there because I've taken way too much of your time.
Oh, it's just neat to see what you did. Just really impressive.
I wanted to ask you guys. I know I sent that out to Jerry about the higher water levels globally, and if it's affecting weather, and he just simply said, no, Tim, it's really the water temperature.
Yeah.
What's this one?
Plus acidification. Well, this is for Ron. This is how that Newtonian scope works.
Yeah, there you go, Ron.
You called the mirror a cave. Is that a brand?
Yeah, Tom Cave.
Yeah, I think the guy's name was Thomas Cave.
Yeah, Tom Cave. Yeah, and he made really good mirrors, and every now and then not so super good, you know. But it sounds like Tim got a really good one, you know.
It was. I put it up on the rack, and I got a I looked at it with the Ronchi Ronchi pad.
That's Newton. That's Isaac Newton.
There's the original Newtonian.
Yeah.
Really?
Yeah.
And it's a mirror in the back,
I
right?
remember it.
Yeah.
And did you see the focuser arrangement on that on Newton's scope?
Yeah.
Where he's basically moving the tube in and out.
Yeah.
Oh, wow. That's interesting.
It's attached to the globe.
Yeah, that's the mount.
That's
the
cool.
mount. Doesn't look like there's much holding it.
Yeah, see, I can't on mine. When I rack it all the way in with some of the eyepieces, it won't. It just on the edge of focusing, so it needs to go in further. So Joe just said, just move the mirror cell up, and that'll give you that down focus that you need. And to be honest with you, that little shorty tube, it's pretty heavy on the back anyway. So if I move that up, it's going to make that balance even better. So it might work pretty good. Yeah. It was a fun project, and there was a lot of really neat things that surprised me. The tube itself, it seems like there's a thin layer of wood that's sandwiched between layers of fiberglass and epoxy, and yet at the same time very light. The cave mirror, that mirror cell was made for this tube only. It was pretty nice.
Yeah, maybe you could make a wooden shim, Tim, a wooden shim to push that mirror forward, something like that. I wouldn't cut holes in that nice little tube. It's too pretty.
Yeah, I don't know how I would do that. I just I'm thinking,
one of your wooden rings.
Well,
to push the darn thing forward.
I understand the technology, but old man Galileo didn't have any of that, did he?
No, he didn't.
He built refractors. Yeah.
Just two lenses.
And to have, having tools out in the backyard, my workshop is literally outside, and I made
I noticed you had to displace the cat.
Yeah.
Yeah. the cat, by the way, Bamboo, she approved of the scope. She said it's pretty good.
That's pretty good.
So it was fun. I'm sorry I took so much of this time, but it was a neat project, and I hope you enjoyed it.
Tim, going back to your question about what's this about Florida being flooded, and how does rising ocean levels affect the climate? Is that what your question was?
Yeah, it was would the rising seawater globally, is that going to change our weather, or was the weather what really caused the ice, the ice caps to melt and raise the water level, and that's what caused it. And then,
it's the weather causing the ice to go away, which is raising the sea level. But that's going to affect weather in the sense that when you have hurricanes and typhoons, the storm surges are going to go quite a bit more inland. And most cities around the world with large populations are on shorelines.
Yeah.
And it's going to be a big problem.
Yeah.
I think
climate change, if things are getting warmer and there's more energy in the atmosphere, I think it is, and then
more energy in the ocean.
Jerry said that he sent me some info back saying it's the water temperature rising because of global warming, and that causes the storms to be more intense.
Yes.
And he said, really, the only thing about Florida is just it'll just disappear. And, I mean, there's some people that won't mind that.
So I read vacation Disneyland.
I read that there were some Southwest Pacific islands. They're trying to figure out why they're not disappearing. They're building up again, even though they have lost a few of those Polynesian islands. Folks have had to move. They were so low anyway, but others are regenerating. Have you read that, Chuck?
No, I haven't seen that.
Well, my son's girlfriend, she's actually a professor out at UCSB, and it's in the global global warming. It's
climatology.
It's environmental studies, and she went to, what is the name of the islands? She actually went to these islands, and parts of the island she was standing in water, and she was just saying, "This is crazy. This is nuts. It's already happening."
Yeah.
You know, I think my brother-in-law Ron Nixon was telling me that there's a trough in the North Atlantic that the water dives down. It dives down to the bottom, and the temperature down there really dictates what a lot of the weather patterns we're having in the Southern Atlantic. Now, I'm not too sure of that, but he was emphatic that there's something going on there that's kind of like a water pump that's deep down in the Northern Atlantic.
And what happens is that's what pumps nutrients, up and spreads them through the ocean for the fish life and whales and stuff. And also some of those currents drive not the jet stream, the Gulf Stream.
Yeah.
And that's weakening, and that has a big effect on the weather in Europe.
Right.
And
right.
Yeah,
it's a mess. And then I was going to go on to that. I was going to say that if you have a rising water levels, Chuck, what is that tidal changes? Are those tides going to really change stuff? That would be one of the biggest questions.
Plus, you're going to intrude salt water into a lot of the aquifers along the
you bet
coastlines where these cities are. There's problems everywhere. Plus, it's acidifying and it's killing off corals and who knows how much the fish can stand.
Well, I'm negotiating to buy some beachfront property in Greenland.
Yeah.
We have run out of time. It's been interesting. I'd love to say we can do this without you, Jerry, but we really can't.
Or Tom.
Sorry, I got my computer screwed up this time.
Oh well, that happens a lot.
Ron, I'm comfortable whenever you're here. I feel okay. I feel like we got it covered. I used to listen to you on the radio, and you are amazing. So it doesn't bother me at all.
Well, I'm just along for the ride, gentlemen. I keep learning. I keep waiting to get my diploma in this incredible university.
No way, man. You are the man.
Well, look, that was episode 179. Next week, the meeting on Friday night will be behind us. We're going to have Professor Volganov from LCO talk about beer in space, ether and the ethanol. That's Friday night at Fleischmann Auditorium. We'll be back on next Monday. That'll be 5 days before our next meeting on screen, Saturday, the 10th of August. And that's also hopefully a beautiful post-fiesta star party.
Yeah.
Incidentally, speaking of that, Viva la Black Hole and Dark Matter and AstroUnit.
Yeah.
Next week.
Yes,
See you Friday
Thanks,
night.
everybody.
All right, guys.
See you Friday.
Bye.